Hello, you are watching an interesting video about amyloid plaques are found in the brains of people with Down syndrome and Alzheimer's disease. Please read this disclaimer carefully. By age 40, nearly 100% of people with Down syndrome develop the brain changes that produce Alzheimer's disease. Now, a new study claims to have revealed the mechanism that puts people with Down syndrome at such high risk of Alzheimer's. Down syndrome is caused by the most common chromosome abnormality in humans, an extra copy of chromosome 21. About 1 in 700 babies in the US are born with Down syndrome. As well as a mild to moderate intellectual disability, a characterizing adverse effect of Down syndrome is the increased risk of Alzheimer's disease. By age 40, nearly 100% of people with Down syndrome will have changes in their brain that lead to Alzheimer's. 25% show signs of Alzheimer's type dementia by the age of 35 and 75% by the age of 65. As people with Down syndrome are now living longer than ever before, average life expectancy is 60 today, but was just 25 in 1983. Research is addressing how the quality of life of people with Down syndrome may be improved. The researchers, from the Sanford Burnham Medical Research Institute, found that both mice bred to share characteristics with Down syndrome and humans with Down syndrome have significantly lower levels of a protein called sorting nexin 27, SNX27. SNX27 plays a role in maintaining receptors on the surface of brain cells. As these receptors are necessary for neurons to fire properly, lowered levels of SNX27 impair neuron activity, which leads to cognitive problems. Also, SNX27, the team found, regulates beta amyloid production. Beta amyloid is the sticky protein toxic to neurons, which, along with dead neurons, clumps up in plaques within the brain. These plaques are considered to be the hallmark of Alzheimer's. We found that SNX27 reduces beta amyloid generation through interactions with gamma secretase, an enzyme that cleaves the beta amyloid precursor protein to produce beta amyloid, says Zhen Wang, Ph.D., first author of the publication. Wang adds when SNX27 interacts with gamma secretase, the enzyme becomes disabled and cannot produce beta amyloid. Lower levels of SNX27 lead to increased levels of functional gamma secretase that in turn lead to increased levels of beta amyloid. The researchers found that these lower levels of SNX27 in people and mice with Down syndrome are caused by an extra copy of mRNA 155, an RNA molecule encoded by chromosome 21 that influences SNX27 production. Defining the complex mechanism driving Alzheimer's Down association. Mapping the process that leads to this outcome, the researchers found that the extra copy of chromosome 21 implicit in Down syndrome causes elevated levels of mRNA 155, which lead to reduced levels of SNX27. The part of this cascade that leads to Alzheimer's is that the reduced levels of SNX27 lead to an increase of active gamma secretase, which boosts production of beta amyloid and, consequently, the plaques in the brain that cause Alzheimer's. We have defined a rather complex mechanism that explains how SNX27 levels indirectly lead to beta amyloid, says Oxy Hu, Ph.D., senior author of the paper, adding, while there may be many factors that contribute to Alzheimer's characteristics in Down syndrome, our study supports an approach of inhibiting gamma secretase as a means to prevent the amyloid plaques in the brain found in Down syndrome and Alzheimer's. The findings are important because they explain how beta amyloid levels are managed in these individuals. Interestingly, the researchers found that by adding new copies of the SNX27 gene to the brains of the Down syndrome mice, they could repair the memory deficit exhibited by the mice. The next step for the team is to develop a screening test to identify molecules able to reduce levels of mRNA 155, which will help restore levels of SNX27. The team also wants to identify molecules that can enhance interactions between SNX27 and gamma secretase. Recently, we ran 2 spotlight features on Down syndrome. The first asked if expectant moms are receiving adequate information on Down syndrome, and the second looked at current areas of research in Down syndrome. Notes and references.